For this Quideo, question A asks you to use the computer output above to determine the equation of the least squares regression line and to identify the variables used in your equation. So my equation is y hat equals 0.240x plus 0.317. And I got these values from the computer output under the coefficient column, and that told me that the y-intercept is 0.137 and the slope is 0.240. So the variables in this equation are y and x, and y shows the electricity that is produced, and x is the wind velocity in miles per hour. Part B asks how much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 miles per hour than on a day when the wind velocity is 15. So to do this, I plugged 25 and 15 in for x in my original equation. So for the first equation, I have y hat equals 25 times 0.240 plus 0.137, and this showed me that it's predicted that this wind velocity would produce 6.137 amps of electricity. And then for 15 miles per hour, it predicts that it will produce 3.737 amps. And then I subtracted 3.737 from 6.137, and this showed me that it's predicted that 25 miles per hour wind velocity will produce about 2.4 more amperes than 15 miles per hour. And lastly, Part C asks what proportion of the variation in electricity production is explained by its linear relationship with wind velocity. And so I used r squared value from the computer output, and that showed me that 0.873 of the variation in the electricity production is explained by its relationship with wind velocity.